more stuff to burn, basically, so you get brighter and hotter. That's a great supposition, but you have to go out and actually test that. That's what's actually causing it. Basically, what it means is mass is the controlling variable. Everything else about the star depends upon its mass, the main sequence star. Once you specify its mass, you know just about everything else about the star. You know how hot it is, you know how bright it is, the composition of all the stars are basically the same. The size depends upon the mass. You can see that those diagonal lines cross the main sequence the same way that the mass did. Okay, it's slightly different, but everything about the star is determined by its mass. So basically, the mass is the main determinant of what the star looks like when it's a main sequence star. That sounds unhappy, right? We think stars. So we've this diversity of stars. Well, now we've understood what the cause of that diversity of stars is. It's their mass. Their mass is controlling their diversity, at least for 90% of the stars. People have a mystery about the other 10% of the stars. They don't follow this pattern, and we'll have to, but we certainly understood 90% of the stars, and that's pretty good.
Do you work this Saturday?
So here I'm getting to that. 1% of the stars are giants, 90% are main sequence, and 9% are dwarfs. These three classes are cooler and bigger, middle and hotter and smaller, respectively. What might this tell us about stars in general? And this is, at this point, idle speculation unless you've read ahead in the book. Yeah.
The cooler the star, the bigger it is, the hotter it is, the smaller it is?
So that sounds great. The cooler it is, the bigger it is, the hotter it is, the smaller it is. That's not entirely true, right? Because you can have stars, if you look at the middle of the HR diagram, there are stars, this is constant temperature. We have stars at the same temperature, some of them are giant, some of them are main sequence, and some of them are dwarf, which is a reflection of their size. It's kind of true, but it's not completely true. There's something to what they're saying, but not completely true. Anyone else want to hazard what that might mean about stars? Well, so when they first saw this HR diagram and realized that there were these three classes and stuff like this, people began to speculate on what it means. There were various speculations. One of them was like, well, it's telling us about the life cycle of stars. And the argument was, hey, maybe they start as kind of big, diffuse things, and they gradually shrink with time. And they shrink and they get hotter and brighter, or they get hotter, not necessarily brighter, because they're getting smaller. Right? So a star basically starts shrinking with time, and what you're seeing is young stars or giants, middle-aged stars, adult stars, as it were, are main sequence stars, and then old stars are dwarfs.
Does their mass remain the same?
So something is funny about that, because remember the giants didn't have the really low mass stars, and the dwarfs didn't have any high mass stars. So you have to, if it was true that it was a life cycle, you'd ask, well, what the heck is happening to the masses of the stars to explain that? Others had the opposite idea. They said, oh, no. What happens is the star starts as this little hot thing, and that little hot thing grows into a main sequence star, and then at the end it grows into the giant star. Again, and so the argument there is, oh, it accumulates mass, and only the most massive ones can turn into giants.
That's why you couldn't zoom in.
Trying to answer the question of what about the mass. At this point, we don't know the answer, but these were speculations at various times that it was telling us something about the life cycle of stars. But what it is, we don't know yet. So this is not stuff for the examiners. The HR diagram is telling us something about the life cycle of stars, but we don't know what it is. And we have to speculate.
I recorded it.
So as people discovered about relativity, they were starting to say, well, maybe that has something to do with the life cycle and how it works.
Why stressed? Why
Again, I'm going to defer answering the question until we get to it. But that's the sort of speculation scientists don't yet know what the heck is going on. This is, how it works. You make a hypothesis, especially in astronomy, you make a hypothesis, explain the existing thing, and they all sound kind of plausible, right? Both of my arguments, starts as a little guy, grows and grows, right? That sounds plausible.
That sounds plausible.
Start small, get bigger.
You can't hear him though. He talk loud enough.
The other hypothesis is
critical
equal
thinking,
plausible at this point. We really don't know what the answer is. So we'll come back. And one clue is those hypotheses would have to explain, well, why are 1% of the star giants 90% main sequence and 9% dwarfs?
Because they get smaller.
You have to, sort of explain why does it spend most of his time as an adult middle-aged star and such a small amount of time as the other two.
Do you know why they're 1% of giants? Because they get smaller.
All right. So questions? I'll quickly go over the review material. Yeah.
This guy's only 1%. 90%.
So again, we'll have to try to, we don't know the supernova or another phenomena that they seem to be related to stars, but at this point we don't know what the heck those are. What they need about where a star is. We don't know the answer.
I went to the game this white bit. They do nothing. The game ain't come up. I think I put like
Maybe there's some other.
Where'd you park?
I'm on the street. I parked way in the back. Yeah, when I swiped it, the gate didn't come up. I didn't went to another park. I swiped it, it didn't come up. So I had to ride out of the pad tonight because they said it.
All right. Reminder what we talked about for example 2.
So you need a park there.
First talked about light and telescopes.
Wherever I want to
We
park,
talked
maybe.
about the nature of light, that is that they're electromagnetic waves, and they also have aspects of particles.
This morning.
The only sort of number that I would like you to remember
The slides.
speed of light, 3 times 10 to the 8 meters per second.
They're on Blackboard.
I give you a formula, if you need that, we're not gonna get that.
Let me hear.
That's a number you gotta try to remember.
Ask it.
The basic wave equation, that speed is equal to the wavelength times the frequency.
Show
We talked about how all of the
That's real.
light derives from what atoms are up to, so we hit the structure of atoms.
We gotta know the equation.
Nucleus in the middle, electrons whizzing around at specific energy levels.
What equation? Number 3.
Inside the nucleus, protons and neutrons, and what a great secret this is, where it tells us about how the world works. We talked about then how the structure of energy levels leads to spectra from atoms. Specific colors, wavelengths, or frequencies, or energies, depending on how you want to look at it, of light, come from specific kinds of atoms. Hydrogen has its unique spectra, helium its unique spectra, etc. This is vital for us understanding stars.
You don't
We're
have to
able to figure out
apologize. Just
the composition of stars by studying their spectrum. We talked about the electromagnetic spectrum. Basically, the energy of the little packets of light are given by h times the frequency. I would give you h, that's not something I'd ask.
Is it gonna be on Blackboard?
The nature of light then depends on, it doesn't matter how you want to talk about it, either the wavelength or the frequency or the energy, because they're all describing the same thing. Right? Because the wavelength determines the frequency from the equation that I had earlier, speed equals frequency times wavelength, and because the energy is given by the frequency, it also determines the energy. So while it looks like they're a very different phenomena, that is, X-rays do not look like visible light, they're actually the same phenomena, and how they differ is just that they have different wavelengths for different frequencies and different energies. We talked about the spectrum going from long to short wavelength, starting with radio, very long wavelengths, microwave, shorter, infrared, the visible, the mnemonic, keep track of the colors,
I got all
Roy G.
this
Biv,
in my notes, I think.
red,
I got all
orange,
this.
yellow, green,
I
blue,
think
violet.
I wrote all this.
I have Kate and Ann remind me of it. Ultraviolet, X-rays, gamma rays, shorter and shorter wavelengths, higher and higher frequencies, and more energy. And then we importantly talked about the atmosphere's effect on light, how it absorbs light in various regions, and that there are two windows, visible light and radio, thus leading to visible light and radio telescopes being Earth-based, while the other telescopes have to go into space. Right? Because their light does not really penetrate down to the bottom.
Man, yeah.
This is all up on Blackboard.
Yeah,
Set
this
up.
and just to make sure that I can't afford not to be doing it if it is. You know,
That's why you ask the question.
if it was a
That's why
fit,
you raise your hand and ask the question.
if it was a fit, we'll all be drunk right now.
I
If
typically
it was
ask
a
the
fit,
question
we'll all
of
be
where
drunk
would
right
you
now.
put
I'm
this
recording
telescope?
We're recording him so that you
Sort
can
of question,
use
or why
this
is this kind of
Blackboard
telescope?
and this study.
That's
So
the
that
sort of
you
question
missed.
I ask. I could, if I was really, think that's what I am.
I'm gonna put
I
you
ask,
down
can
on
you
the
draw the
computer and I'll put it in
show the two
that you
windows?
take home and put it on your
That's a
computer and
mean
listen to it.
I wish you'd been doing that from the beginning.
But I would highly recommend that you look at that diagram.
It's good.
Try to
I'm studying
understand
this.
Right, this-
Showed it a number of times, at least
I
twice.
need that song on.
Then we talked specifically about telescopes,
I have my
the difference between reflectors and refractors, and on why reflectors have displaced refractors
You use it to study
among
now.
modern telescopes. We talked about why the telescopes get bigger and bigger, both for reasons of light gathering, to gather the known possible light to see the faintest possible objects, and for reasons of resolution. Bigger telescopes have better resolution, they're able to see more detail. And then again, why some telescopes are on the ground, some telescopes are in space.
You just keep looking at my lips. You don't watch it.
We then came back to atoms and talked about spectra,
You know what you
the
think.
black body spectra, which leads to us being able to figure out the temperature of an object by looking at the spectra. How that allows us to,
Oh, man.
based on the star's color, we're able to
Telescope,
figure
I
out.
think I got all this stuff. He gave us this spectroscopy, and all this gonna be on his own too, like.
We then pointed out that because of the structure of atoms, that leads to spectral lines.
I guess, I don't know. Hold on.
And thus you have three types of astronomical spectrum, the black body spectrum, dense solid objects,
I can't go, I'm going off of what I
dense
know
hot
before
objects.
you came with that, so that's
The
gonna be a
emission
bonus.
spectrum, where you just see the emission lines of some thin gas that's been heated up, or the absorption lines where you see some thin gas between you and the emitter of the
I know you do.
black body.
I like you in the morning.
Pointed out that you can measure forward and back
couldn't
motion
remember
of
what I
things
said
by
to you
looking
this
at the
morning.
Doppler shift,
The fall, you hear my
plus the
phone ring?
spectral line
5 o'clock in the morning, or
around.
till 6 o'clock
By
in the
looking
morning.
at that, you can tell if the object is moving towards you, away from you, how fast it is.
Did you?
Round.
Made my bed messy.
Help you
Pillowcases have come.
remember that goofiness, that helps you understand. Think about it.
Good. I mean, it's wild and willy. Yeah.
We had a whole lecture on the sun,
Give you something to do.
what it's made of,
Keep you
what
busy.
its structure is,
Position
the
strong.
features that we see on
What
it,
do you mean keep me busy?
sunspots, solar cycles,
Clean up the bathroom.
surface, sort of weather, quote, weather phenomenon of the sun, and its very problems.
It says shows the future spots.
I was doing the
There was not
trying to
meant
clean
to
up
be more there.
20 minutes.
Forgot to get rid of that comment. And then crucially, we talked about what powers the sun.
That will get you cut off.
The nuclear fusion of hydrogen to helium is the power
That's
source.
what's going on. This is a lifelong thing right here. You my wife, you can put me in.
Emerson, that's your mouth.
And we talked about stars,
Don't get scared.
As you smoke
their
it.
basic properties, luminosity and brightness, and then how distance allows you to translate between them. Measure the brightness, you know the luminosity, brightness is how bright it appears to be.
Yeah, want some gum instead?
Measure the luminosity, which how bright it intrinsically
How
is.
does that
The magnitude system, which is our goofy system for measuring brightnesses.
I'm coming here.
I don't actually know the details of the magnitude system. You have to know what it's for. Stellar spectra, look at the stellar spectra, what we see in those and what we can get out of that. How we can study binary systems and measure stellar masses. And finally, how we can measure stellar sizes.
You want a whole one?
And we spent 2 classes in
I left it in the
showing
refrigerator.
you the HR diagram. What is it?
You want another piece?
What do we see in it? And what do we
You get me some.
almost guarantee we have to draw out. I think that's it.
Take a quiz.
Exam is the same format, 25 short answer questions, 1 or 2 quantitative questions, 3 or 4 draw questions. The others. Some things that can be answered in 1 word, some that